Hello, on this video I would like to go through the TI-Nspire, some of its features that you use with statistics, and how to get a one variable statistics set. So get all your statistics out of the TI-Nspire for a set of data like you'll see in front of me. And we're also going to take a look at box plots, how to change from different graphs like box plots to histograms and things like that, and how to adjust the scales of those. And then in other videos, we'll do things like how to calculate outliers and how to calculate standard deviation in the other videos in this set of videos. So let's get our one variable stats to begin with. What I have in the data sets here are the semester 2 grades from my AP Stat students and my geometry students from 2020. So these are their grades from last year. I had 23 AP Stat students and I had 62 geometry students. So there's a difference there. But what you want to do, it doesn't matter if you click over here, wherever you click. I usually kind of go here because I want my statistics to end up right next to it, so I don't have a blank column in the middle. And you go to your tools, which you can do over here, but I like to keep that on the page sorter, but it doesn't matter. And then your tools, statistics, on the handheld, that'll be menu, right? The tools is the menu button. And we go to stat calculations, one variable stats. You'll see a two variable here, but even though I'm going to do two sets of data, I'm not really comparing those or putting them together or anything. I just want one variable stats for both sets. So I click that. You'll see here it says how many lists. I want two lists because I'm going to do both at once. And just to keep things organized, since my AP Stats is first, I'll do that one, and then my geometry second. And it asks you where you want to put it, in column C or wherever. So I've already set it up for column C. That's where I want it. So great. And you can change that to D or E or whatever if you wish. But once you hit OK, then your stats will pop in there. It tells you what it is here on the left. And then if you kind of forget which one these are, if you go into that cell up the top in the formula bar there, I can see this is the AP Stats set of data. And this one over here is the geometry set of data. You can, of course, adjust these if you want to see it more or less or whatever. I'm just going to kind of keep it over. Let me shorten these a little bit so I can see my statistics a little bit better. There we go. Okay, the first one, you got your mean. And they have similar means. Most of my classes end up like kind of a B or B plus average, right in that range. Then you have the sum of all your values, if you ever needed that. Sum of the squares, which when you're doing calculations for statistics, when you're using the actual formulas and how standard deviation and things like that works, sometimes you want these data points. Here is the actual standard deviation. There's two of them here. The difference is that this first one is for samples. If my data came from a sample of a population, this is the standard deviation I want to be using. It introduces a little more error because it is a sample, it's not a census. The standard deviation that you see here with sigma, that's if you did a census and you know all the data for the whole population, which is kind of what I have. This is all my geometry students and all my AP Stat students. There's nobody missing. So this is the standard deviation I would want to use. You can see how these numbers up here are just a little bit bigger. Instead of 111 down here, it's 113. Instead of 0.0822, it's 0.0829, so just a little bit bigger. Like I said, it just introduces a little more error. So this one divides by n, and this one divides by the n minus 1. So that by dividing by n minus 1, it'll introduce a little more error. You get a little bit bigger of a number for that. Okay, so this is how many elements you had in your set, 23 and 62. And then we get into what we're going to be looking at today is the 5-number summary. The 5-number summary is just kind of a good, in a nutshell, describing your data set without actually drawing it out or anything on a graph. So it tells you the minimum, maximum. So we got the upper and lower bounds to that set. If I subtracted those two, I could get the range. And then it's broken into quarters. And just like what the median is broken right in the half, right in the middle. So 0.86 is 50% of my data is below 0.86 and 50% of my data is above 0.86. Same thing over here, right? And then we break that half again into half, so into quarters. So 25% of my data is between 0.6 and 0.7. 25%, if I didn't say that. 25% of my data is between 0.7 and 0.86. 25% of my data between 0.86 and 0.91, and then 25% in between 0.9 and 0.99. 0.91 and 0.99, right? So these are the quartiles, we call them, right? There's a quartile here, here, and here, and here, right? So there's 4 quartiles, should make sense. If you want to get your interquartile range, which is your middle 50%, then I would take my 0.909 and subtract my 0.716, and that would give me my middle 50%, like the range of the middle 50%. So we have the overall range from minimum to max, and then we have the middle 50% range, which we call the interquartile range, or the IQR, from there to there, right, from Q1 to Q3. So let's take a look at this 5-number summary. When you do a box plot on your TI-Nspire, this 5-number summary is what they're using to draw your lines. So I'm going to insert a data and statistics page. Just click one of your variables on the bottom. Let me just do both. I'll show you how. Again, we're not comparing these sets. We're just trying to describe them. So I'll put in the AP stats. If I right-click on this, I can add an X variable. So I will add an X variable, and I will add in the geometry because I don't have that yet. So now I have both here, my AP stats on top and my geometry on the bottom. And this is just a dot plot. And you could describe a data set like this. I can see, the spread of this. I can see a lot of information just from a dot plot. So there's nothing wrong with a dot plot. We use it quite a bit in AP statistics. We use these a lot to count data points, like trying to find the quartile by counting it. You may even do a simulation and then have a dot plot there, and you might have to come up with the percentile rank of a particular number or something. These numbers are they have, if you look at the data set, they have 3 decimal places to them, right? So that's why these don't line up very nicely, because you got 3 decimals going on, and they don't stack very well. So it's you won't see it quite like this when you're asked to count something, but you can still get a lot of information about the shape of it, the spread of it, where the center is. You can do all those things with this. Okay, so if you want to change it and get a different view, you go to plot type here up in the tools, and we have blocks plot. We have histogram available to us. Let me do histogram first real quick. So histogram looks something like that. You can see the borders of my histogram don't line up very nicely. So I'm going to change my plot properties. You can go to histogram properties. They have the bin settings here, and you always want equal bin width. So let's do that. You can change the scale to like percent or density, but let's do that after. So equal bin width, and you can say, well, how wide do you want these to be? These are grades, so let's go by 0.05. 5%. Let's go by the 5%, and then you want to start this off at a nice even number. So I'll start it off at 50% and go by 5%. And let's see what that looks like. Okay, so that gives me kind of an idea. You can play around with it manually. I can grab these scales and adjust them manually so I can see the top of it. And there you go. There's a histogram, right? That's really good to kind of describe things. This is kind of uniform. I don't have a lot of data points, but there's obviously more up in the upper grades than there are the low grades. Same thing here, a lot more in the upper grades than lower grades. It is unimodal. I could kind of estimate where the center would be if I needed to on these, right? Maybe you can see how this one was a 83, I believe, right? Like down in here. So that kind of makes sense, like right in there. And then the other one was like 87 or something, wasn't it? So right about here was the center of my geometry class grades. I might say this is skewed to the left, but it's kind of a weird graph. Like you might have to describe how the upper set above 80 looks a lot different than the set below 80 on this data set, right? You have to describe those unusual features. Okay, but let's go to a box plot. That's supposed to be the focus of this little video. So we'll put a box plot on there. So back to 5-number summary, 0.6, 0.7, 0.86, 0.91, 0.99. That should be my AP stats, right? 0.6, right? You can hover over this and see the numbers. There's your median, there's your quartile, there's your maximum. So you can hover over and see those. Now, we haven't calculated outliers yet. I'm going to do that in a different video, show you how to calculate outliers manually, which you need to know how to do. And but for now, I just want to show you that you can, let me find it here. Where did it go? There's a way to turn on and off. Oh, right here. Extend box whiskers, the box plot whiskers. So if I want to click on that, then if there were any outliers, they would show up as little dots on the ends where those outliers are. And we don't have any in this case. It's not showing up. So I'm going to click this show box plot outliers and turn it back. But we don't have any, so they wouldn't come up. If I did have any, this whisker would be shortened, and you would have an outlier, just a circle on the ends of these, and it will show you those outliers. I don't have any outliers in this set of data, so they just don't show up. All right, and that's it. You can describe these, like here's my center, 0.86. Here's my center, which is the median of 0.87, right? I can describe the shape. Mostly, just looking at the box plots, this is mostly symmetrical, maybe skewed to the left a little bit, and I know that because this tail has been pulled out longer than the right hand is. Same with this one, it's skewed to the left because the minimum and this first quartile has been skewed out to the left more than the right side has. So I would say it's skewed to the lower numbers. This is slightly skewed to the lower numbers. Really, it's just because of those unusual kind of features, right? The upper set and the lower, upper half and lower half kind of look different when you look at those histograms. Okay, so that's center shape, and then the spread of this, I would look at the range, 0.6 up to 0.99. So that's 0.39 about, 0.38, 0.39 would be my range for this set. And you could also talk about the inner quartile range for your spread as well. We're going from 0.9 down to 0.71. So what is that, 0.19 about, right? You could subtract those and get your IQR. So the IQR is a indicator of spread, and so is your range. You could do standard deviation. You can actually just quote this standard deviation or this standard deviation. Either one's fine. You can quote those and just use those as a measure of spread. This has a spread of 0.11. This has a spread of 0.08. Obviously, this one's a little bit bigger, so it has a little bit more of a spread on my AP statistics set, which you can see in the box plot. It's a little more spread out. That's it. So just kind of looking at box plots, looking at the 5-number summary and how to use those to make a box plot, and then talking about the big 3 to describe data sets. Center, shape, and spread. But don't forget about those unusual features. Look for the other videos to talk about calculating outliers and other things for this section.